Hello, my name is Jay Kinsey. I am a judge for the first Lego League competition, and today we're going to talk about the mechanical special features section of the FLL robot design checklist that I made. So, under mechanical special features, the first thing we have here is dedicated motor core. What dedicated motor core means is that effectively the entire robot is an attachment. So you'll see robots like this sometimes where the programmable brick and the motors are all in one tight pack, and that EV3 or that programmable brick and those motor pack are effectively moved from one base to another, and thus basically turning the entire robot into one giant attachment. Multi-gear ratio transmission is a function where a team will actually have some kind of a transmission for the drivetrain that will allow the robot to switch gears. So, for example, they could have low gear for more torque and precision, or they could have high gear for more speed. Power switch route is also kind of a transmission thing, but this is more for having some kind of internal system that will move power to different parts of the robot. So, for example, if a robot has, let's say, two arms, let's say they have an arm on the front and an arm on the back of the robot, right? They might have some kind of a power switch inside where the motor torque is routed either to the arm on the front or the arm on the back. Stuffed wheels is kind of an interesting subject. It used to be in the old days that there weren't quite the diversity of wheels that are available now for the competition, and so teams would take wheels that were kind of squishy, and they would stuff the insides of these wheels either with corrugated tubing or with bushings or pegs or some other Lego part that fits well inside. And the reason why teams were doing this was to make the wheels significantly harder. Because a hard wheel, a good hard wheel, won't deform under load, and thus it keeps a consistent radius, and then that reduces air when traveling. Suspension is what it sounds like. Some robots do have some kind of a little bit of extra spring system built into it just to help keep the robot level and even. Also, like when the robot's changing directions and things like that, it can be helpful to have some kind of system inside the robot to absorb shock. So, suspension. Here we have full wheel wells, and then also by extension semi-wheel wells. Full wheel wells means that there is a external support on the outside of the robot that actually supports the outside of the wheels completely. So if you look at the standard tribot, like the standard NXT tribot or the equivalent for the EV3 system, the wheels on those sort of basic kit robots are not supported on the inside or on the outside, and because they're not supported, the axles tend to bend up and out, and when that happens, then you're changing the radius by which the robot turns, which will not do good things for your odometry. Let's just say. Semi-wheel wells are the same idea as full wheel wells, although the wheels are not fully supported, they're only partially supported on the outside. Matched motors is a function where some teams will actually find two motors, and they'll try to find motors with similar characteristics. So, for example, I've seen lots of teams where they have a motor, two motors that are attached to a differential, and then they'll see which way the differential spins. So if the differential spins one way, then they know one motor is faster than the other. And even with the EV3 and NXT that have odometry built into the motors themselves, matching your motors can still give you some really good results, especially because the firmware that actually does the synchronization in the EV3 brick when both motors are told to go forward is not perfect. So it'll fishtail a little bit, by matching your motors, that'll help minimize the fishtail effect that you have when going straight. Um, Brick color property. This is an interesting one. Um, so this is less commonly known, but it's certainly very important. It turns out that different color bricks have different mechanical properties. Um, we found this out the hard way, like back in 2005 when we had two skids, and one of our skids was yellow and the other skid was black. And after running a robot very intensely on these two skids the whole season, we found that the yellow skid had this huge wear mark in it, which was actually causing the robot to turn, and the black skid had no wear on it whatsoever. Um, and we actually followed up with Lego to confirm this, that that the coloring additive that they put into yellow, um, in the other colors like yellow, blue, red, actually makes them mechanically weaker, than some of the other colors like black. Um, Light sensor shield. So it's always good to shield your light sensors from outside light, even though that the new light sensors are more resistant to external lighting conditions. It still helps them out to cover them, so external light doesn't change your readings. Uh, Wheels yoked is also pretty interesting. Even though the modern NXT and EV3 can track their wheels evenly because the motors have odometry, they're not perfect, and so in some cases it can be beneficial to yoke the wheels together in some way with like some kind of a limited slip coupling or some kind of a friction coupling, um, to help promote the wheels to turn together. Um, Obviously, if you put in too stiff of a coupling, the robot will not be able to turn. If you put in too loose of a coupling, it'll have no effect. So you have to kind of find a happy medium for your robot where um, it will have enough. It'll have enough grip basically, so that both wheels can be forced to track together, but you'll have enough energy to overcome that resistance when you go to turn. So thank you for your time. This concludes the video on the mechanical special features function for the FLL robot design checklist.